Hey guys, so welcome to the Algebra lecture, where we're going to have a look at a number of questions related to algebra. Okay, so this question says, at an internet cafe, Bella uses the computer for J hours in a 24-hour period, while her sister Celia uses it for 1/7 of the remaining time. For how long does Celia use the computer? Okay, so let's quickly write out the major bits of information here. So Bella uses the computer for J hours. Now, the important part, guys, is that it's in a 24-hour period. So she is using it for J hours out of 24 hours. Okay, so if she's using it for J hours so I'm just going to write it here, out of 24 hours, that means the amount of hours that she's not using it is simply 24 take away J. Because out of the 24, she's using it for J hours. So 25 minus J equals hours Bella is not using the computer. Not using the computer. Now that we know the amount of hours that Bella is not using the computer, we can move into the second part of the question, which says, Celia uses it for 1/7 of the remaining time. So now that part's really important. So the remaining time is 24 minus J. So Celia is using it for 1/7 of 24 minus J, which is simply 1/7 times 24 minus J over 1, which gives me 24 minus J over 7 hours. Okay, so to answer this question, for how long does Celia use the computer? Therefore, Celia uses the computer for 24 minus J over 7 hours. Alrighty, now let's move to the next question. Okay, so this particular question says that Ryan buys a bag of X lollies for his classmates. If he divides them equally among R people, how many lollies does each person get? Now part B says, if he keeps half of them for himself and divides the remaining amount amongst R people, how many lollies does each person get? Okay, so once again, let's write out the most important parts of the information. So Ryan has X lollies. Now A says, if he divides them equally among R people, how many lollies does each person get? Okay, now to make things a little bit easier, let's use a few numbers here. So instead of X, let's assume that X is 10. And he's now, instead of R, let's say R is 2. So he's dividing 10 lollies amongst 2 people. So all we have to do to figure out how much each person would get is simply do 10 divided by 2 to give us a 5. However, as we know, we don't have these values. We simply have the letters X and R. However, the operation remains exactly the same, so it's still X divided by R. So if he divides them equally among R people, how much does each person get? They get X over R lollies. Simple as that. Now, moving on to part B, it says, if he keeps half of them for himself and divides the remaining amount amongst R people, how many lollies does each person get? So once again, using those same numbers, if he had 10 lollies and he kept half of them for themselves, so 10 divided by 2, which is obviously 5. Then he divided the remaining amount, which is the 5 here, amongst R people. So each person would then get 5 divided by R. However, as we know, we don't have the number 5 because we didn't have the numbers 10 and 2 to begin with. What we did have were X, which is the amount of lollies he has. He divides it to 2 because he keeps half of it. And then he divides the remaining amount, which is X divided by 2, amongst R people. So X divided by 2 divided by R. So we have X over 2 times R becomes 1 over R. Because as you know, the bottom number or the denominator for R is simply a 1 here. So we have X times 1, which is X. And then we have 2 times R, which is 2R. So how many lollies does each person get? Therefore, each person gets X over 2R lollies. Okay, let's move to the next question. Alrighty, so this particular question says, Brian has a piece of string with him that is 20 centimeters long. Now, if he cuts off d centimeters, how much of the string is left? Okay, so let's just quickly draw this out. So we have a piece of string that is 20 centimeters long. So remember, guys, if it's feasible, if it's something that can be drawn out, please do draw them out, because having it as a visual aid really does help you answer the question. Now, it's a 20 centimeter long string. He cuts off d centimeters. So say he cuts it off right there, and that portion right there is d centimeters. So the question is, how much of the string is left, which is this part here? So if that d was instead 5 centimeters, so let me go back to the same color. Imagine if that was 5 instead of d, and if we had to figure that out, all we would have done is 20 take away 5, right? However, we obviously don't have the number 5, we have the letter d instead. So if we were to figure out part A of how much of the string is left, then 20 minus d centimeters of string is left. That's how we would answer the question. Now, guys, the reason I always like to use an example with numbers is because it helps us rationalize the answer a lot easier, because we are used to numbers when it comes to math. However, when it comes to algebra, and when we're just getting used to the concepts in algebra, we do obviously have to deal with letters instead. So this is just a simple way to understand the question by using numbers. However, obviously, this is an extra step that I'm using to show you guys. There's absolutely no reason for you guys to be doing this extra step. Just go straight to the answer. Okay, part B. Now, if he cuts off a quarter of the remaining piece, how much has he cut off? So if he has a remaining piece of 20 minus d, right, that's how much he has of a remaining piece. Now, he has cut off a quarter of that 20 minus d. So we have a quarter times 20 minus d. So 1 over 4 times 20 minus d. Now you'll notice I keep putting it into brackets just to signify that 20 minus d is the total answer. It's not just 20 or d on its own, it's actually 20 minus d as a whole, which is signified by the brackets around them. Now 1 over 4 multiplied by 20 minus d is simply 1 times 20 minus d, which is 20 minus d, over 4 times 1, which is 4. So if he cuts off a quarter of the remaining piece, how much has he cut off? He has cut off 20 minus d over 4 centimeters of the string. Now, it says, part C is how much of the string is left now. Now, guys, he had a string of 20 centimeters to begin with. Then he cut off d centimeters. Then he cut off a quarter of the remaining piece. So if he cut off a quarter of the remaining piece, that means 3/4 of it is still left. So that's the answer. So 3/4 of the remaining piece, which is 3/4 of 20 minus d, is the amount left. Simple as that. Because once again, guys, he had a piece of string which was 20 centimeters, then he cut off d centimeters out of it, then he cut off a quarter of the remaining piece. So after he has cut off that quarter, there is 3/4 of the string still left. Alrighty, so now let's move on to the next question. Okay, so this particular question says, a rectangular park that measures 150 meters by 70 meters has a path put in around the edges that is g meters wide on each side. What is the area of the park? Okay, so first, let's quickly draw out the information that's been given to us. So we have a rectangular park that measures 150. So that's 150 meters by 70 meters. Then it has a path put around it that is g meters wide. So I'm going to use a different color just so it stands out. So we have a path put around it. Now, obviously, guys, this is not to scale, nor is it super accurate. It is just there for illustration purposes. So it has a path put around it that is g meters wide. So on each side, it is being extended, I guess, if you want to look at it that way, by g meters. Now, what is the area of the park? So that's a fairly straightforward question. A, because it's obviously a rectangle. Now, the area of the park is simply 150 times 70. Now, we know 15 times 7 is 105. And then we have the 2 zeros at the end to give us 10,500 meters squared. Then, part B says, write an expression for the area of the park, including the path. All right, so now we have to include both the path and the park. So the length here, so let's work out the length first. So length is, let's call that the length. So the length there is 150 plus the g on both sides. So we have plus g, which can be this g here, and then plus another g, which can be this g here. So it is 150 plus 2g. Now, on the other hand, we have the width as well, which is the 70 meters plus g and plus g as well. So we have 70 plus 2g. So that's the length and that's the width. So the area this time around is now length times width again, which is 150 plus 2g multiplied by 70 plus 2g. Okay, now part C says write an expression for the area of the path only. So now, guys, they're only asking for this blue area here. So that's the part that they're asking for. So the area that we just found, again, I'm going to use a different color, is this entire thing here. So if I was to minus the area of the park, which is this pink bit there, that's the park in the middle. If I was to minus that part from the area that we just found, we would be left with the area of just the path. So we have C, area equals 150 plus 2g, 70 plus 2g, minus 10,500. Okay, now I'm running out of space here, so I'm just going to quickly get rid of some of this information here. So I don't think we quite need that anymore, if I'm not mistaken. Hopefully we don't need it anymore. Oh, I dropped out a little bit too much. Let me go back. Quickly get rid of this again. All right. Okay, that's good enough. Okay, so part D says, if the path is 1.6 meters wide, what is the area of the path? So again, we have the area of the path here now, which is 150 plus 2g multiplied by 70 plus 2g minus 10,500. So for the first bracket, it could be 150 plus 2 times 1.6, remember, which is simply 3.2. Then the second bracket can be 70 plus 1.6 times 2 again, so again times plus 3.2, minus 10,500. Okay, so we have 150 plus 3.2, which is 153.2, multiplied by 73.2, minus 10,500. Now I'm going to put this straight into the calculator, which gives me 714.24 meters squared. So to answer this question, what is the area of the path? The area of the path is 714.24 meters squared. Okay, let's have a look at the next question. Okay, so this question says, Agatha is reading a novel where the pages are 14 centimeters in height and 8 centimeters in width. She notices that the words are written p centimeters in from the top and bottom and I centimeters in from the left and right. Part A says, write an expression for the height of the page where the actual words are written. Okay, so let's again draw this out. So let's say that's our page right there. Imagine we have some wording here, wording there, and wording there. Okay, now it says that Let me just go back to this. It says it's 14 centimeters in height and 8 centimeters in width. So this is 14 centimeters and this is 8 centimeters all up. She notices that the words are written p centimeters from the top and p centimeters from the bottom. So this bit there is p and this bit there is p as well. And the second part says, and I centimeters in from the left and right. So again, that part is I, and that part is I as well. Now, obviously, I haven't drawn this really well, but I'm hoping that you understand it. So it says, write an expression for the height of the page where the actual words are written. Okay, so now the total height of the page, as we can see, that total height is 14 centimeters. However, the words are actually written p centimeters in from both the top and the bottom. So 14 minus p for the top and minus p again for the bottom, which gives us 14 minus 2p centimeters. So that's the actual height of the page where the words are actually written. Now part B is obviously working with the width. So our entire width there is 8 centimeters. However, it's being brought in I centimeters on each end. So again, we have 8 minus I again, which gives us 8 minus 2I. So again, as centimeters. Part C tells us, write an expression for the area of the page where the actual words are written. So now that we have found the height and the width, all we have to do for the area is simply multiply them, because we know that height or length, whatever you want to call it, is simply that multiplied by its width gives us the area of a rectangular shape. So height in this case is 14 minus 2p, and then width in this case is 8 minus 2I. Multiplying them through, we get centimeters squared. Now guys, you can expand this if you like. I'm not going to do it in this case because that's not the main aim of this particular question. So guys, that brings us to the end of the algebra chapter. I really hope that was helpful. There was a few very typical sort of questions that you're going to see at this level when it comes to algebra. We're going to sort of build on this a little bit, build on the concepts a little bit more in the linear equations lectures. So guys, again, thank you for paying attention. Make sure that you have a go at the worksheets, and I will see you in the next lecture. Thanks, guys.